So guys, welcome to the developer meeting on July 27th. And I'm giving over to Carlos.
Yeah, so the changes that I've made was I created this camera to eCAL. So this was before, and it was just basically calling the camera controller that you developed. And then I added basically the get and set functions in there. And now at this stage, I added also the eCAL interface. And so, but because I don't have the camera, I created also this webcam controller, which is doing the same thing as the camera to eCAL, but it's using a normal camera. And then the other idea that we were talking about was to have an eCAL monitor. And so I did also the monitor in there. Um, so this monitor just does is a simple interface, and we can show it. But yeah, maybe probably go through the eCAL, the camera to eCAL. So what this does is that so it has a controller which is now separate from the camera. So this main controller. So this part here is for eCAL. And then what it starts basically is going to start the capture. So this is going to trigger the camera side. And then this is going to just basically get a status from the camera process. And when we stop getting a message from the camera, um, then what it does is that it's going to kill the process and restart again. So if the camera gets blocked for whatever reason, we just trigger it again and try to reset it again. And then it has a maximum number of attempts. So in this case, it's going to be, I think I've put to 5 attempts or something like that. So if it doesn't restart, then we need to check it. It might be the USB connection or something like that. Then we need to do something about it. But that's basically the idea of this loop. It's just that we were talking about having the master code or the monitor doing this, but it's better to do it on this controller so that it just triggers it. The other thing as well is that so when we start the process, we're going to start this process here. So this is what I did before, that is just calling the camera. And so you can see that here we're controlling, getting your camera live frame. And then I've integrated here the protobuf, which is going to basically, now it's going to just send the image inside. So this is just capturing the image from the camera and sending through eCAL. And then it's sending the status message to the main controller, and is receiving also a configuration parameters from the main controller. And so then once we get a parameter, then we're going to just set it on the camera. On the main controller, we get the signals, the status from the camera, and they are broadcast through eCAL. And also the main controller receives the parameters from eCAL, and then it's going to just send it to the camera. So it does this interface. That's basically it. The monitor. What the monitor is doing is that it's just getting the status, and it allows to send the messages to the camera. There were some bugs that I've added. I need to push here. Not much. So it was just because of the I'm using the multiprocessor to calculate the process, and yeah, I need to have this pawn here. But that's just a difference in Ubuntu. Um, yeah, I'm going to run both. I already have it here. So I have, in this case, I'm going to use the camera controller, because I don't have the camera. So this is using my USB camera. And then I can open the monitor on this side. So this is the basically the interface on the monitor. Is it moving? Yeah. And so what this monitor does is that you can set up the parameters here. So in this case, I'm initializing with default parameters that you had. And when I applied parameters, it's going to push. And in my case, because they don't mean anything to me, I'm just printing on the process so that I know that I'm receiving the parameters. And so if I change here to 1, the exposure, then it's going to update in the background. Then I have the option to reset. But here I'm going to experiment. So let's say that something goes wrong with the camera and I close it. So what's going to say is that the camera has crashed and it's going to reset the camera. So if the real camera crashes, this is going to reset it. Also equivalent, we can reset from here and it's going to do the same thing. It's going to reset and restart again. I have also the option to close the camera. So this will just close, but for now, let's leave it there. And I have the option to visualize the camera. So that opens just an interface here to visualize. And the button is switched off. So when I just close this window, then it activates again. Another thing as well is because I'm have a multicast set up on it, I can have it the controller or the monitor on my Windows in this case. So this is running on Windows, and it's the same thing. So if I set up this to 2, I can send there, so it applies the parameters. I can reset now from remotely from Windows, and this is resetting in there. And I also have the viewer running from Windows as well, and yeah, it works the same from Windows side. So when I open, I just see the monitor in there, and I can now close it remotely. So now I'm closing from Windows, and this is just going to terminate on the other side, basically. So yeah, so this ecosystem between them. Oh, it opened another one. Uh,
Okay, cool.
yeah.
Uh, I, I have some questions. I have some questions noted. So what I saw, there is something that you call pulse. Is pulse a feature of eCAL, or did you just give it another name?
And no, yeah, so this I created here basically. I can close this. So yes, so basically what this is doing is that on the camera monitor, I'm going to I'm going to receive the status from the camera, and basically I just created this what I call the pulse timestamp. Um, so that's basically
It's a timestamp.
that I've put it. Yeah, I just get the timestamp from the camera, and this is acts like a pulse. So if the camera gets blocked, then it doesn't send the pulse to the main controller, and I know that something's wrong, and then I can basically restart. So yeah, it's here on the controller. So if I'm getting the status from the camera, one of the status is going to be the pulse timestamp. And then if I don't get this pulse, so here I'm checking if I don't get the pulse or it's bigger than the timeout, that means that the camera is blocked. And then what I'm doing is that I'm just restarting here. I'm terminating the process and I'm starting a new process.
So
So
did
basically restarting the camera.
Yeah. So did I understand you right? The pulse is a timestamp of every frame that is created.
Yes, yeah,
Yeah, okay, I get it.
timestamp as
Okay, it's the timestamp, the latest timestamp, let's say.
and the post timeout. I'm defining it here above. Um, so yeah, so this is 5, but we can define depends how much it is.
Yeah.
If it crashes, then I'm going to give it more time to restart.
Yeah.
And then I have in this case 3 attempts. So if it doesn't restart in 3 attempts, then it just closes and doesn't do anything anymore.
Pulse timeout of 5 seconds means the time between kicking the process and the process being restarted and being sending camera available.
No, so this the restart is going to be 30 seconds. So I'm giving it a
There are
lot of
two.
time, and yeah, the pulse time would be the frame rate. So if you have 1 frame per 5 seconds, then this will not work. So 5 seconds
Yeah,
is more than enough
yeah, yeah,
to
yeah.
test.
Okay,
Yeah.
understood. Yeah. Brings me
Yeah.
to the next question about you're in the right file. Can you scroll down to your loop, where your main loop is?
Hmm. Yeah.
Yeah, somewhere you catch the frames somewhere in this loop. Well, where is it starting with the frame?
Oh, that's in here. Yeah. So here I'm getting
Yeah,
with
genau, exactly.
in
Yeah,
this case it's going to be from the right.
yeah. So
Yeah.
this while loop, do you anywhere control the timing between calling the frames? Or is get live the initiation of
Um,
the function and it runs by itself?
yeah. So it runs by itself. So it's in the while loop. When we get the frame, if there's a frame, then we do the rest of the processing, and it just goes in a loop, waiting for it. Um, so yeah, that's basically it. We're just testing it.
So the, the camera controller itself has its internal loop, right? To keep the target
Mm.
FPS. Okay, and this loop here is in the eCAL camera to eCAL
Yeah.
script, let's say, um, where you actually also in the same loop. You need to be also in the same sync with the camera or not, or do you just if frame is none, you
So
just recall?
this is the one that I've it was the same code that I had before,
Mm-hmm.
that you tested already.
Mm-hmm.
That I've put it on a separate process and
Okay.
added the eCAL on it.
Okay.
The same thing. So this is calling directly the camera controller from here.
Okay, and it did work because last time we checked and it worked on my side. So
Mhm. Yeah,
okay.
you can test this again. It's just that I need to push ahead those issues with the multiprocess.
Mm-hmm.
I have to push those corrections, but then we need to test, see if this is working.
Mm-hmm.
Last time we tested it, we were seeing the image, so now it's just adding the controller.
Yeah, I'm just worried about sending too many requests that the camera can't handle, and
Mhm.
we fill up a buffer until it fails.
Yeah, we can have a time delay here or something.
Yeah, it could be that
Yeah.
we have to calculate here as well.
Mhm.
Okay.
But for
Um,
now, it's actually hopefully it crashes so that we can test the functionality.
yes, yes, of course. We already tested it. I think, what was it, 2 weeks or 4 weeks ago? 2 weeks ago? You know,
Yeah.
when you helped me with the eCAL installation, then
Yeah.
we made that running on my side, and it worked. So
No, but I mean the crashing part. So to see if this can reset it and restart it again, that will be.
that it
Yeah,
does
let's
it
see if
by,
it works.
that it does it automatically.
Yeah.
Yeah. Okay. Um, I saw your parameters of your interface, and your in your code you reference this in the ProtoBuf messages. Christian, are you with us, Christian? Can you hear us? Yes.
Yes.
Um, Carlos, can we just run through all these parameters?
Mhm. You mean on the eCAL side or
Yeah. Yes, let's stay on the eCAL side. Yeah.
yeah, so basically we have the proto files in here. And so I have basically the status and the parameters. Parameters, it was the ones that we set up on that spreadsheet that you had. And so I'm using this as an example,
Yeah.
but different ones.
Yeah.
But yeah,
I want to
so it's
discuss.
the target brightness,
Yeah.
target grain,
Um,
again, exposure as well, and so on.
Carlos, sorry to interrupt you. I want to discuss with Christian, because we also need to bring Christian up to where we are right now, because Christian was, let's say, for 3/4 of a year almost hospitalized. So he needs to catch up. So I want to, what we did, explain to him so that he can understand what we did, and yeah, can say whether we are on good grounds or what his ideas or add-ons are. So Christian, oops.
Yeah, I was just going to show. So this is the camera controller. So this is based on your code, and basically it's just wrapped around a class. But it has the auto exposure controller, and then it has the main controller in here. So this is what we are calling.
Yeah, can you go back to your protobuf so that we see the messages or the name of the messages? Yeah, that one. Cool. So Christian, just to explain to you what you see here. Target brightness is a value that is used for the auto exposure. I set this for now in my script, but of course it's changeable as we saw. I set it at 0.5, which means 50% between white or black. So in the middle. That needs to be adjusted over time. So on daylight, we have a different target brightness as in night. And what the auto exposure is doing, it calculates the current brightness, and the difference is the brightness error, and it tries to compensate the brightness error. But it can also only do it in one step behind, because you can set gain and exposure just for the next image, of course. So you're running behind. In order to do this, I used some smoothing and, you know, all this kind of having curves that are convergent, kind of. So target brightness is a value that we need to control. And I think we can very easily experiment with this, just to let it run in the outside and see where it goes under certain light conditions. Let's say track this with the snapshot or something like this. So then the next value is target gain. I can recall a discussion with you about efficiency. And there are two, I hope I say this right now, crossing curves between energy output and kind of an amplification or so. It's two curves. And these curves, maybe I'm totally wrong here, but please correct me. These curves are particular for every camera. They're different, of course. So
Yeah.
for this camera, the QHY, the target gain when it is 22, gain is 22, then it has the most efficient situation on output. Is
Yeah.
this somehow correct?
But yeah, but it's not target gain. It's the gain value of the chip. Um, the gain value is something that pushes something higher up. It's not the brightness of a target or of an image can be described with all the sources that are in it, and you have got the static in the background, which we call bias. All these, um, yeah, let's say sources of a pixel um, sum up to the brightness of the image, and the gain value is just how much the electron counts are pushed upwards. Mm, I wouldn't call this target gain. I would just call it gain.
Okay,
And
sorry,
I read that you've got a gain min and gain max.
no,
So um,
uh,
if we just call it camera gain,
Christian, sorry,
then we
you misunderstood me. Sorry, there's a misunderstanding. Um, Target gain is a very specific value for each camera. It is the point where the
yeah. So
is
call it
optimum.
camera gain and not target gain,
Yeah,
because target means a source in the image.
now okay, but okay, let me explain in simple words what the auto exposure is doing. So the auto exposure is getting an error, and it tries to compensate for this. And it has two ways. Either it varies exposure or it varies gain. You could do both, but if you do both, then the outcome is more confusing than if you control one for the next frame to come. So I start just with one. So either I do it exposure and do it gain. I gave exposure a priority, meaning if gain is around 22, so if gain, the current gain is around the target gain of 22, yeah, maybe that's a wrong word. Maybe it's misleading to say target gain, but in a sense of the the center point of gain where the camera is most efficient, where the output is most efficient, or something like this. I read this up. You told me about it. I read this up in a paper. I looked it up, the curves for the QHY, and I found the value of 22 as the point, yeah, in
Yes,
gain. So
it's
the
the
sweet
sweet
spot.
spot
Yeah,
for getting um, where the quantum efficiency is
that's the word.
the
Thank you.
highest according to how much photons are transferred into
Yeah,
electrons.
yeah. Quantum
It's
efficiency was the word I was
yeah,
looking for. Right. So the QHY camera has a quantum efficiency max at target at gain 22. That's why I
yeah.
call the value 22 as target gain. So what I'm doing in the auto exposure is I vary exposure. So it's easy to calculate a desired exposure um, because of the brightness error. So you expose until you can't expose anymore. There's exposure max. I use the value of 110,000 for 6 FPS.
You can call it saturation.
Yes. What do you mean is now with saturation? That confuses me a bit.
So if you expose, let's say for 20 or 22 minutes, um, at some point then a pixel goes into saturation, which means that it exceeds the amount of electrons it can
Yeah,
hold in its bucket.
yeah, yeah. There's an
So
overflow. Yeah.
yeah,
Yeah.
No,
hits the
there
kit.
isn't an overflow with CMOS chips anymore. This was
Okay.
with CCD chips. Then they do some kind of bleeding into the next pixel.
Yeah.
But yeah, there are already some CCDs out there, but they won't be used in modern day cameras. Only if you have to make photometry, then you can use a CCD, because then you have to count each photon that is available. But for us, we're using CMOS chips. Yeah, they don't run into the issue of bleeding effects anymore, because they have lines in it where all the electrons
Yeah.
that would run into a different pixel run into some kind of they are they are transferred into a bin, a litter basket, if you call it like this, and they are thrown away,
Mm.
so they are not counted.
Mm.
So
So
yes, you
um,
have if you run into saturation of a pixel.
um,
uh,
the 110,000 are microseconds. So we are
mhm,
talking about 110 milliseconds. And this, of course, is limited by process time and frame per second, target frame per second.
yes,
Because with 6 frames per second, we get divide 100 by 6, and something about 150 milliseconds is max. But we need a buffer for the processing itself.
yes,
So 110, I did a lot of tests, made a spread, so to find where the sweet spot is for every target FPS, and I found it for 6 FPS to be 110. So when target error is still above a certain threshold, then I'm increasing exposure until exposure max is hit. Only at that point, gain is increased. And there are two values for increasing exposure and gain, and it's the exposure min step, that's point number 7, and gain min step, that's point number 8. So that's the minimum increment that is for, there's a little decision tree, and that's the minimum increment, because there's also a threshold. So it only jumps when it's time to jump, let's say. It's not always jumping around so that we get jitter all the time. And we need some stability in the image, because the background subtractor is very much relying on a stable image in terms of exposure and gain. So changing exposure and gain very much will very much inflict the background subtractor. So every time we change exposure and gain, we also have to pause the background subtractor wait in the background subtractor, sorry, my tongue. We need to pause it in order to create a new history, because there's a new situation on the exposure and gains on the camera. So the image is totally different now. The background subtractor would be confused, too many foregrounds, that is not something we have to desire. So and of course, exposure is a minimum and a maximum, and gain as well as a minimum and a maximum. Of course, both start with 0. But now, let's assume we hit gain at, let's say, 30 for something. And exposure is at 110. And we have an error that is almost 0. And now the light darkens. So we can go back with gain until we're going back to 0. We're going back to the target gain. We're going back from 30 to 22 until we reach 22, because we're then on the sweet spot, and then we decrease exposure. So only when target gain is only then when gain is at target gain, we run exposure. If exposure hits a min and a max, then we run gain. If gain is a min and a max, then we run nothing anymore, because there's nothing to run anymore. So we stay there. And if no, what was the last case? No, why? Yeah, so the priority is on as long as target is as long as gain is target gain, the priority is on exposure. But if exposure is at min or max, then the priority is gain, of course, until exposure is moving again. So kind of a freezing there. And we always try to go back to target gain and the variable vary exposure to a desired value if it is all within the range of exposure min and max. Yeah. Long story short, that's more or less the auto exposure.
Yeah.
We can control this here. Yeah,
I
sorry.
get the concept. I would call the target brightness image brightness and the target gain camera gain, because this renaming implies a better understanding for
Naja,
the concept here.
yeah, but think of it. We have a gain and exposure value for every frame that we store. Every frame that
Yes.
is
But that differs
acquired.
from the sweet spot gain of
Yeah.
each camera.
Yeah,
Because
sweet
each camera
spot
has
gain has a specific one. Yeah.
yes, and these can be changed according to what should be uh, achieved. The target gain, for example. So what we are
Camera target
calculating here is some kind of signal to noise value. So if the signal to noise value is max, then the tracker works best.
Yeah.
And the background subtractor does works best. And what we gain is that the the background of the image, the real background of the image, that is defined by the noise and dark current that is subtracted, everything like that, then the source in the image is very high and the background of the image is very low, and the gain value, the sweet spot gain, defines the range of this. So if the range is high, the background subtractor, so the information background subtractor, works best because it can determine a very high contrast between things, and it can the dynamic range of the values is very, very high. So we have plenty of values to say, okay, an object, for example, let's take a sphere. The object can be detected very good on, let's say, a very dark or a black background. This, for example, is the optimum that you can get. So you can determine a point spread function on it, and this point spread function almost goes from 0 to 1 in this background in the not in the background subtraction, but in the signal to noise value. So if we rename these both target brightness and target gain to something different, for example, camera gain, we can use the target as other parameters to determine if the tracker and therefore the background subtractor are working best. Do you understand what I mean?
So you have a difference between a camera target gain and a target gain that you want to use for something different. That's what I understood.
Yes,
The difference I did not understand.
yes, because we can produce a function that determines very quickly um, if our image brightness and if the exposure time will set this image brightness correctly. So if we use a signal
Okay.
to noise
Now I
value
get you.
as
Okay, you want to automate this so that the target brightness
yes,
is calculated on the fly because of timing or position, geo coordinate, and as a day of time and cloud coverage and whatever have you.
yes, correct.
Okay, 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 okay. I didn't know where you were leading us here, but now I understand. Okay, Carlos, just for your information, because it could be that you didn't follow as well. So what Christian is meaning with target gain renaming is, so what we have here is target brightness and target gain, as it is very specific for target brightness a specific time on the day, and target gain being very specific for the camera itself. So to call something a target gain for when we have other cameras in the future makes it a kind of odd. And for second, he wants to use the target gain value as something to calculate a real target gain besides the camera target gain
Mhm.
to find out what is the correct
Specific
target
to the
brightness.
scenario.
Yeah, exactly. Yeah. Okay. I think, Christian, somehow we understood.
Yeah.
Okay.
Thanks.
Okay.
Yeah, a target is something in the image. Is part of the content of the image, and
Okay.
if we call it image brightness, then the whole image mm, is meant, and we call it camera gain, then it's the gain value of the camera chip.
Yeah.
So
Yeah.
the overall gain, and
Yeah.
since
Sweet spot of the
every
camera.
pixel has a different gain because every pixel has a different gain factor because the amount of electrons that are it's the ADU value if you call it like this. So this gain value here means every gain factor of every pixel. So we call it camera gain.
Yeah. Okay. Okay.
Then it's quite
Mhm.
clear and
Yeah.
close to
Yeah.
the definitions of the ones who created it.
Mm-hmm.
So, but I like what you did here, Carlos. Yeah, when we
Okay.
started out last year in October, getting the cameras run with a single shot version, um, I like what you did to this in the last 6 months.
Mhm.
Okay.
Yeah, we also have been working on the background subtraction as well. But yeah, we need to push that a little bit more as well. Um, but we have two different versions.
Yeah.
Yeah,
And Carlos wants to combine both at the end in the
yeah,
node. Yeah.
Yeah.
Okay. Let me
it's a
just.
good idea to do that because just there are plenty of background subtractors out there, and to see which one is working best or a combination of it. Um, yeah, for the daylight, it could be one version, and another combination of other background substructures are working best for the night. We have to see which one is best, and maybe switching
Yeah.
from or having three, one for dawn situation, one for or if we can create one that works best the whole day because it decides according to the signal to noise ratio what the settings are. Yeah, we have to see that. I think it's a
Yeah,
lot of testing.
yeah. Another thing as well is because the background subtraction being the mixture of model or vibe, they tend
Yeah.
to accumulate the information. So then we have what is called ghosts, objects that leave and leave a space behind. So
Yes.
those kinds of issues. And so the idea is to have something that learns fast, like the
And
3-frame difference
and the
and the
smearing
other
of
method.
CMOS chip goes into that as well.
Yeah. Yeah, so this allows to detect, and also there's the blob detection that is commonly used in astrophotography to detect stars and things like that.
Mhm.
So anything that is a blob separate is going to be detected.
Mhm.
Yeah, so if we have, and these are low cost type of detectors, so it allows us to combine and have a better detection overall. Yeah, but we need to push a little bit more on this.
So the dog blob detection, you said something. It sounds to me as if it's already existing, right?
This is generic, so there's already implementations of it.
Okay.
You have in OpenCV and things like that. It's very basic implementation.
Ah, you mean the OpenSea implementation? I get it. Yeah. Mhm.
Yeah,
Okay.
yeah, there's already implementations for it.
Yeah. Get it. Carlos, can you just jump back to the proto? Yeah, this one.
Mm-hmm.
I just wanted to finish with two important steps. No, values. Sorry. Compensation factor. Christian, compensation factor is a controllable value. That's my very private experience with this algorithm to approach a fast auto exposure that does not overcompensate and does also not overshoot and does not oscillate and does the convergence in as quickly as possible way. So I use the term compensation factor in a sense that I don't want to compensate for 100% of the error because I would in because I can only measure the current image and decide what the next exposure gain is. So I can only run behind. So that means it's very easy to overshoot. Okay.
Yes.
Um, but yet to be fast, I need to be close to a higher value than to a lower value, let's say. Um, so this is compensation factor is like you could say a percentage of the brightness error that needs to be compensated in every loop. So every frame that's coming in, auto exposure is adjusted in parallel. Um, so whenever you compensate, let's say, I think now it's on 0.62 or so. So it's 62%. That gives a good convergence within, I think, 4 to 5 frames. Um, and but it does not much overshoot because 62 is rather low. Yeah, that's why this is a factor that we can change. I don't know on what intelligence or knowledge or data we can change it, but this is something we can certainly adjust if needed. But I have no idea now how to calculate what is the best compensation factor, for a certain situation. We just have to experiment with this, I think. Okay, and then the last one is target temperature. And that's just a thing that you set anytime you want to change the target temperature. As the temperature controller in the camera does this all by itself, you just give it the target and it does it within fast time and no oscillation and perfect. And within a certain threshold. that you cannot even control. So it's a fixed threshold. So this is on the camera parameter side, but the camera is also outputting something.
Mhm.
Carlos, can you show us the
So
proto
this
of the
comes out of
Yeah.
the stats.
Mm-hmm.
So basically, we have the temperature, gain, and exposure. That's the only three that I have. The rest are
Yeah.
basically for the control part.
Yeah. Yeah, exactly. So, Christian, so that you know what this is, with every frame that is acquired, we have a timestamp, we have a current gain with which this and exposure with which this frame was produced, and we have, of course, the current temperature. And we store this. Now we can not only store this, but also propagate this. So these are the values besides the frame itself, the frame data itself. If you have any more thing that we need in the future, we can add this here.
These values are saved with each image,
Yeah,
or
yeah,
okay, so each image is put as chunk into some kind of, let's say, we already have some kind of buffer. We call it NumPy array, I think, or we've
yeah.
called it NumPy array.
And it's running in a shared memory for now.
Yeah. So if we write that down for the archive, let's say we have to think about how we want to build the archive, the archive structure,
Mm-hmm.
I would say. So if we are using what was decided in the earlier, we said let's go for the HDF5 structure, then we could call these four values that we have here at the moment, we could write them into the header of the image. And let's say we have 200 elements in our NumPy array, then this array could be written down into the HF5 file, and we have to decide how we do that. If we produce one HEF5 file for each target, this is the target that we detected in with the tracker, or if we produce an HDF5 file of HDF5 files, because we could do that too. I don't know
The
what's
good thing with eCAL is that we can record all of this,
yes.
and so it's going to basically the structure of the file is based on the protobufs. So whatever we define in the protobuf is the way it's going to be recorded. And also with eCAL, we can define to record per channel as well. So whatever goes on in the channel, it goes into its own file, basically.
Yeah, with the FITS format we're using in astronomy, we produce or we can have a different header for each frame. So the FITS file contains can contain whatever you like, from spectral data to image data to whatever. And the HDF5 is a much more sophisticated, um, yeah, let's say, data format. So
Mhm.
this, what you have here, could be the header data of it.
Yeah.
So what the
And
question?
the good thing about eCAL as well is that we can record and then have, so basically eCAL then has the player, and we can then play everything as if it was running live. So for us to develop, it's quite useful.
Yeah.
And so here they basically have an application that is the recorder, but we can define our own application as well. So just using Python, and we can call it and run it as we want.
Yeah.
But yeah,
Yeah.
and there's already one implemented here as well. So a recorder and a player. So I have the eCAL player and the eCAL recorder.
Yeah.
Okay, and it's all defined by the ProtoBufs.
Yeah.
So the question that Christian arose was whether there is a difference in storing the data hierarchically, horizontally, or vertically, meaning either we do it if there are several events at the same time in the same frame. Is this then one HDF5 file or are these two? Or do we substructure? What I would suggest.
Yeah. I would say it depends on how we collect the events. Um, so if we say, okay, one event per image, or if we say in an image there are several events, how are we going to deal with that?
I think that's the
I
normal.
think
I think you always have.
synchronization could be by timestamp, right? So we say for the image with a certain timestamp, then we have the associated detections on it.
Yeah, yeah,
Hmm.
yeah.
So the protobuf for the detections, you have the detection list, and it would have its own timestamp referring to the image, so that everything is synchronized.
Yeah, because the problem is if we detect, let's say, in one image 5 or 10 um, if the tracker detects let's say 5 to 10 sources in an image, and we later find that in let's say in an image here an event occurs, and this event, yeah, will occur here, and it is the same target in the image. How we deal with that,
Hmm.
because it then
Mhm.
afterwards it's the same object.
Yeah, but this
Yeah.
is a question of the
So the
tracker
thing is that
itself.
yeah, more on the detection, I would say,
Yeah.
because what Christian is saying is, if the object moves from one side to the other side of the image, then yes, we can track it. But if it's on the right side of the image and then some frames later is on the left side, then we need to have some kind of a descriptor to be able to say, oh, this was the same. It's just
Mm.
that it moves so fast
Mm.
that we can't track it. And so that falls more on the object detection. If we can have like sift features and that allows us to have a descriptor for the object, or then we need to have some kind of CNN to classify the object so that we know that it's the same.
Yeah.
Um, I think the main problem for me with the large number of objects is going to be to the PTF,
Mm.
because the PTF is mechanical and it's not able to pinpoint each one of them fast enough for a frame.
Now,
Yeah,
but we have to go
that
for
will
this.
Yeah.
Yeah, sorry. We have to go for the strategy of the low-hanging fruit. So the low-hanging fruit first. Check
Mhm.
it out, make a classification. Interesting or not? Next one.
maybe I was thinking of the problem for prioritizing which target will will be hunted down first. Um, I think for our first Allure version, there could be some kind of algorithm that decides which is the object with the highest priority, and afterwards, if we can afford it, then we can add some more PTFs to cover that ground.
Yeah, but this is the reason why we
There's
have
another thing as well
classification.
that
Sorry, go ahead.
there's another question as well, which is that if we want to track an object, so if there's an object of interest, the PTF tracks it and then keeps focus on that object. The other option is that we have a list of objects and we want a snapshot of each one of them. And so basically then the PTF is going through the list until it takes a snapshot of each one of them. Then when it's done, that it goes back to the same list as long as there's a list in there. So I've worked on a project before, but this was surveillance on a bank. So when people go on a bank, you have the normal surveillance cameras, but you can't really identify the person. And so the idea was to have a pen and tilt camera that will focus on the person's face and take a photo. So now you have 10 people going into the bank, and basically we're just taking a snapshot of each one of the faces, making sure that it was identifiable. So it will be the same concept. You just, whatever objects you have, you just make sure that you have a snapshot of it, or versus having to track them over time.
Yeah.
I want to bring us back to the storing situation for an event. So let's assume, and I think this is the normal, we have several events at the same time, because there's always a plane, a bird, an insect at the same time, let's say, and a UAP, of course. We of course have the classification that runs over all these events, and the HDFF content is event-based. So we're so when the first event that occurs that is tagged as unknown, let's say, because we couldn't classify it. We could classify it as a. We could not classify it as a bird, not a plane, and so on. Then we call it as let's say a hot event or something that needs to be recorded. But that should be configurable, I think, so that people who are interested in birds could select birds as hot and not unknowns as hot. You know what I mean? So if an event is hot, then at the same time it could be several events at the same time. Even if we detect, let's say, an unknown, not classifiable, there certainly could be others that are not classified yet. We have to run all the classifications over it. And still we could end up with several unknowns at the same time. We probably will be, I think. So in this case, I would say the first event creates the event tree where the event gets a number or so, or a timestamp or an ID, I don't know. But then we have two sub-events in the same frame. But it also can be that one big event only has one event, which is just a single sub-event. You know, guys, what I'm saying? Because at this point, we can also add events from the PTF as well as sub-events. And this brings me back to the question of the HDF5 file, Christian. I think we were talking about this a year ago, where we said we structure it so that we have a meta HDF5 file, let's say, containing a lot of HDF5 files. And every one is an event, is from a certain sensor, from the same event from several sensors, or several events from their several sensors. But they all come together in a big HDF5 file for that moment in time when this event was alive, or these plural events were alive. Can you
For me,
recall?
that would be a database,
Yeah.
right? Because I think it would be more efficient to use a database. And the other thing as well is that you can plug in with your laptop, have access to the database, and get the information.
Yes. The idea was that we can that we have a good image of that database because um, hmm,
Aren't
I
we?
think we have to talk. I think we have to talk about how we structure this database.
Didn't we had that discussion already a year ago, as I can recall it? We were talking
Yes.
about the graph database because this is pointing like in a folder structure to particular data points and store this as a dump into an HTML5 file, creating all these levels of events and sub-events and sub-sensors, what have you. Is this
Even
still?
if it's an SQL database, because then you can have an interface, a web interface as well, that you can connect. If this is plugged in through Ethernet, then you can plug into it. But you can physically go with your laptop, connect to the station, and access the database. It will be more efficient. You get all the information.
An SQL database is not efficient for that because you have to look things up because it's a sequential query language. A graph database has some advantages over that because you can track any event in real time. SQL databases are not real time databases.
Yeah.
And that's, we talked about it last year around this time. Which database could be the best, or which database could, or is there a database that can, let's say, track real time events and merge them? For that, we didn't progress. We didn't have plenty of progress to decide which database is the best. We talked about it with Yannick. We discussed it in our science advisory board, and I think one reason why we dropped it was, or we put it in the background. We reduced the priority of that was because the it was not necessary for our actual problem of releasing the lower version, and that's why we put it in the background. I think.
Okay, but we are stuck at the moment right there where we are stuck a year ago regarding this topic. And I think it doesn't make sense to wait another year. So we need
No.
to have a decision soon.
Yeah, but
Yeah.
one thing to clarify is just that the database is separate from the actual itself. I mean, we're going to have the fisheye image. We're going to do detections on it. If we have a CNN that is fast enough to classify the objects, great. But we're going to track the objects over time and then send the tracks to the PTF that is going to take snapshots out of it. And then the result of those goes to the database. So I don't see the database as a part of this flow chart.
Yeah,
The actual
but
detection.
I think that there are two parts of a database. A database is in one case we are storing events, yeah, that occurred in the past for some kind of yeah, it could be some kind of archive, and a database on another hand is yeah, where we are storing things, and
Okay,
mm,
you
um,
decide between retrieving and storing. So
yes,
in a graph database, as far as I can recall, you have both advantages in one thing. You can retrieve very quickly because there is no real retrieval because you know the path already, and there's storing. The question for me is not a question of, so for example, if we used SQL, let's say whatever SQL, light SQL, what have you,
yeah,
it goes
no,
onto
no, no.
disk in a certain format that is depending on the SQL version we use.
No, I think there's a difference. A database can be how can I explain it?
So you can store paths only. But in this case, if you store paths in SQL, you have a graph database.
Um,
What I meant with SQL is for humans, for us to visualize the events and see what the results.
Uh,
So that's what I mean about database. For me, database is something for us to check later.
okay, so you mean something just for development. So we ran it in parallel just for control.
Yes. Yeah.
mm,
So then you can have a dashboard and you can see the events that went on. That's what I meant about database,
yeah, but there
just in
are
that sense.
I think that on the one hand, we have a database for storage, for archiving things, and on the other hand, a database is a thing um, that collects stuff. Um,
To retrieve an event, for example.
yeah, where we store things. Let's say we have an
History.
HER5 file that could be a database for the real-time things that are going on, and a database, on the other hand, is a storage device. And we have to make use of both, because let's say we have our NumPy array. This is a real life or a real-time database for the event that is occurring at the moment. And on the other hand, an archive is a database that that um, that takes all the events that occurred over a certain period of time, and we can look up if a certain object already occurred, or yeah, and we have to hmm,
Um, a graph database. Please, guys, enlighten me. Does a graph database also allow for retrieval, let's say, give me all events within a time frame in a certain area, for example, in Switzerland. And the data that of this station in Switzerland is writing since a year into HTML5 files. And the events in parallel in a graph database. So would that be possible to have both? To have the HDF5 archive on the one side and the pathing retrieval on in a graph database on the other side? Would that be feasible? Would that make sense at all?
Yes. The structure of the database, or
Yeah, what we need is we need something that points to data within files, let's say, instead of having a SQL dump of a certain region of space on a disk, and the SQL is managing it all by itself. But the only thing we need.
But I think instead of talking, I think the question here is not the system itself. So what, from what I understand from Christian, is that you detect an orb today, and now you need to match through the history to see if you've seen it before. So that's the idea. It's to be able to go back and say, "Oh, I've seen this object a month ago."
Yeah, but both.
So that's the functionality. Yeah.
Both. A graph database can hold up to that, but
The question to me is it retrievable? So can we make kind of I mean, what you were just talking about, comparing with patterns of the past, means another level of functionality. I think what we need is a retrieval functionality where we can say that we retrieve the data that is already stored, not creating new data based on retrievals. So, for example,
What I meant is
yeah,
that the functionality is going to determine the type of storage and
yeah,
type of database that you want.
absolutely.
And so, yeah, I think these type of files, DF files, they are good to store real-time data as it comes along. And later on, if you want to play that data, I think they are very useful for that. The same with ROSBECs. They are the same type of functionality. Now,
ROSBECs.
if you want to have a database, yeah, so ROSBECs is similar, is from ROS. But if you want to have this type of information, if you detect the object today and want to check the history and see if you have seen it before, that's a completely different way of doing it. For those things, I don't think that using these files is useful. I think it would be a different type structure. And even SQL, it will not be efficient for that. SQL, I think it will be more for the human side.
Naja, wait a sec. Let me explain the image recognition part. What we did, I think 2 years ago, was that every event has a certain point of gravity that you can track. Let's say the center point of a rectangle, for example, that uncovers a blob. This center point is coordinated in pixel coordinates. And what we did is we captured 32 pixels to the left, to the right, up and down. So the result is a 64 pixel image of the events. So you see small birds, you see planes, everything. but only in a 64 by 64 pixel resolution, because it's a crop out of the of the frame, of the current frame. So this gives us the possibility to have a certain object with a time sequence. So we do not have to one-shot understand or classify it, but on a sequence. So for example, a bird, you see a lot of different behaviors of a bird, but if you combine them in a string, you can very easily say, as a human at least, you can very easily say that this is typically a bird. You can even say from the different shapes that it makes, that's not bad. Even that is possible. And even if it's only 10 pixel resolution on an object, you can understand this. And Nicola did this on image sequences. So when we store these image sequences, because we have the tracks, we have the gravity points of each track, we can easily store these 64 pixel images in the same structure of the event. And retrieve this sequence could be done by a parallel process looking into various events, image sequences, and combining them or comparing them, not combining, comparing them and finding similarities. And maybe giving priority to the current event. Is the current event in our history somewhere in these sequences? The good thing is these are tiny 64 pixel images. They're very fast to read and process.
But still, like it's more efficient to have to record the full frame,
Yeah,
have the recording of the video,
absolutely.
and the detection is just going to be the region of interest in there, and so you're just indexing by timestamp, and
yeah, exactly that way.
Yeah. Yeah, but I think what is important to understand for the definition of the database, as Christian was saying, was to say, have an event now, you need to compare it with a week before, or even if it's just a couple of minutes before. That changes the way the indexing is done and everything, because now you need to be able to scan and find something similar. Yeah, I need to think of what would be the best thing, but I don't think that HDF files would be the best approach for that even.
I don't want to run in a one-way road here. Christian brought something.
Sorry, actually, I have to go. I forgot.
You need to go. Okay.
Yeah, I have to
So
step out.
just one sentence, Carlos, please.
Yes. Yeah.
Although Christian put this now on the table, I think if it's an interesting aspect, and we certainly should go that route somewhen in the future. But I think it would end for us in a how do you say this, in an end stop at the moment, because we have other topics that need to be done and created. And I don't think that if we could now think about hundreds others ideas, we would not end up with a solution of a certain archive version, HTF5 or whatever, and database. So I would say we stick what we have so far, and we can discuss this later on. We don't have to discuss this finally today, so we can still discuss about it. Let's talk about it next time.
This would be after we have the PTF as well running.
Makes more sense. Absolutely.
Bring up this subject.
Yeah.
My next step would be to work on the object detection. I think just combining the GMM and Vibe and the other functionalities.
Especially what would interest me is how you do the data transfer. So let's say the foreground image pixels or blobs or tracks, or how far you go down. Okay, let's talk about this next time. It's an interesting topic. Okay.
I have to go. Sorry.
Okay. Thank you very much,
you.
Carlos. See
Bye.
you. Bye-bye.
Bye. See you.
So, closing stream. All right. Yeah, Christian, I'm not sure whether we should add more complication at the moment. This is certainly an interesting topic to follow.
Mm,
But if we now go into discussion whether this is a reason why we have to consider in the choosing of database and the archive format.
no, I just want I was going into a different direction.
Okay.
But we don't have to talk about it now. We talked about it last year around this time.
Yeah.
How we store things. We went down the route of storing it was an issue of the recorder and what are we doing with it and what and how we store files, or are we storing anything in files? I think it was the structure that I was talking about. But let's discuss it somewhere else. I think what we have at the moment is good enough to, let's say,
Finally
do
build
something
it.
with the lower version.
Yeah, to finalize it. Yeah, definitely.
Yes.
Yo, okay then. A short question about your eCAL installation. Runs now? Does it work?
Yes.
Cool.
I
Great.
have it running on my Dell laptop and have it running on the Orange Pi 5, but it doesn't run on the Arch installation here.
So on the Orange, you run it on Ubuntu?
Yes.
Okay, cool. Yeah, perfect.
Both Ubuntu versions, the one on the Dell laptop and on the Orange Pi 5, on both it's working.
Okay. Different versions of Ubuntu?
Yeah, the one is on a Dell laptop, the other one on the Orange Pi 5.
Yeah, but the version number is 2404, the Noble version.
I think they are the same, yes.
Yeah.
Both on 24.
Yeah, 2404. Right. Okay, guys. I think I can stop recording for today. Any other topic you want to raise, Christian, before I go? Okay. So, bye, guys. See you next time.